Welcome, dear friend, to Luminous Uplift, a quiet place where wonder and serenity meet, and where the mysteries of our beautiful world are shared with the softest of voices just for you. If you have carried the weight of a long and busy day upon your shoulders, you may gently set it down now. Let your body sink a little deeper into wherever you rest. Let your breathing slow like the tide retreating from a moonlit shore, and allow this moment to belong entirely to you. Here at Luminous Uplift, we tell stories that nourish the spirit, tales drawn from the remarkable world around us, offered not to overwhelm, but to fill your heart with quiet awe. Tonight, we drift together toward the great blue expanse that covers most of our living, breathing planet. We are going to the ocean. Imagine standing at the edge of the water as the last golden light dissolves into the horizon, the waves whispering ancient secrets against the sand, the salt air carrying the scent of something vast and timeless. Beneath that shimmering surface lies a world of breathtaking depth and extraordinary wonder, full of luminous creatures, hidden mountains, and stories older than memory itself. If these peaceful explorations bring you comfort and calm, we warmly invite you to like this video and subscribe so we may always find our way back to each other. Now, let us begin our journey beneath the waves. Somewhere right now, in the deep middle of the night, water is moving. It is moving in ways so large and so slow that no single human life could ever witness the full arc of its motion. It is moving in currents that began before your grandmother was born, before her grandmother was born, before the oldest living tree pushed its first pale shoot through the soil toward the light. It is moving in patterns so ancient and so immense that the word movement almost feels too small for what is happening, like calling the sky overhead a ceiling or calling the night a room. And yet here we are, you and I, at the edge of something so quietly vast that the mind, if it lets itself go gently, can almost feel the weight of it pressing softly down like a warm blanket, like the comfortable heaviness of a body finally settling into sleep. Let us begin simply. Let us begin with a number. Though numbers alone can never hold what we are really talking about. The oceans of this world cover approximately 71% of the surface of the Earth. 71%, more than 2/3 of everything you would see if you floated high above this planet and looked down with patient, half-closed eyes. The land, all the mountains and plains and deserts and forests and cities, all the places where human beings have built their homes and buried their dead and planted their gardens. All of that together accounts for less than 1/3 of what is here. The rest is water. The rest is ocean. 361 million square kilometers of it, stretching away in every direction from every shore, unbroken and ancient and deeply, profoundly itself. Imagine, if you can, in this drowsy and comfortable state, standing on a beach at dusk. The sand is still faintly warm beneath your feet from the long afternoon sun, and the air smells like salt and distance and something older than memory. The water reaches toward you and then draws back, reaches and draws back, the way breath moves in a sleeping chest. That rhythm, that slow and patient reaching, is the surface of something almost incomprehensible in its size. Because what you're standing at the edge of is not simply a large body of water. What you're standing at the edge of is very nearly the defining feature of this world. This planet, our planet, could just as truthfully be called the ocean planet, because when you look at the numbers quietly and let them settle into you, that is exactly what it is. 1.335 billion cubic kilometers. That is the total volume of water held within the ocean. 1 billion cubic kilometers. The mind does not have furniture large enough to contain that figure comfortably, and so it tends to slide off it, the way water slides off glass. But let us try gently, not to hold it all at once, but simply to feel the edges of it. A cubic kilometer is already a thing of staggering size. It is a cube of water, 1 kilometer on every side, 1 kilometer tall, 1 kilometer wide, 1 kilometer deep. Fill a cube like that with water, and you have more water than most of the world's rivers carry in a year. Now imagine 1 billion of those cubes. More than that, imagine 1,335,000,000 of them, stacked, arranged, poured, spread across and into and through the body of the earth. That is the ocean. That is what is humming quietly beneath the world's surface right now, while you lie still and let your breathing slow. There's a thought that scientists sometimes use to help put this volume into perspective, and it is the kind of thought that in the right state of mind, in a dark room with soft sounds around you, can feel almost like a poem. If the earth were to become perfectly smooth, if every mountain were gently lowered, and every valley and trench were softly filled until the surface of the world was as even and as featureless as a calm lake on a windless morning, then the ocean, every drop of it, all 1.335 billion cubic kilometers, would spread itself evenly across that smooth globe and cover it entirely to a depth of about 2.7 kilometers. Not just the coastlines, not just the low places, everywhere. The whole planet, wrapped in a layer of water nearly 3 kilometers deep. There would be no land, no shore, no place to stand and watch the horizon. Just ocean everywhere, quietly breathing. That image, that globe of water with no edges and no land, holds something true inside it, because in a sense, before the word ocean was ever spoken, before the first human stood blinking at the surf and tried to find language for the impossible size of what they were looking at, the ocean did not think of itself as divided. It did not know about the Atlantic or the Pacific or the Indian or the Arctic or the Southern. Those names, those boundaries drawn on maps with careful lines, are human things, human ways of making the enormous manageable, of giving names to the unnamed so that we can speak about it over breakfast or write it in a book or whisper it to a child at bedtime. But the water itself has never recognized those borders. There is, in truth, only one ocean, one single continuous body of water connected everywhere to itself, flowing into and out of and around itself in one vast, unbroken whole that wraps the world like something between an embrace and a dream. This is not a poetic exaggeration. It is the scientific reality, quietly agreed upon by those who have spent their lives studying the water. There is one global ocean. We have simply given different names to its different rooms, the way you might have a name for the kitchen and a name for the bedroom, while the air that fills them moves freely from one to another without stopping to check which room it is in. The Pacific is not separate from the Atlantic. The Indian is not a different ocean from the Arctic. They are all one body, one enormous presence, one thing so large that it touches every continent and reaches into every latitude and holds within itself a history that stretches back nearly as far as the earth itself. And the water in that one ocean, that singular seamless body, accounts for roughly 97% of all the water found on this planet. 97%. When you think of water, When you picture it in your mind, the clear glass beside your bed, the rain against the window, the stream that runs through the park you walked through once on an autumn morning and remember now only as a feeling of golden light and cold air and the sound of moving water, all of those things, all of the fresh water in every river and every lake and every glacier and every cloud and every drop of dew on every leaf, all of that freshness and clarity and gentle abundance. All of it together makes up just 3% of the water on Earth. The other 97% is the ocean. Salt and depth and weight and age. The ocean is not a feature of the water world. The ocean is almost the entirety of it. And yet we speak of it so casually. The ocean. We say it the way we say the sky or the ground, as though it were simply a backdrop, a setting for the more important things that happen in front of it. Sailors have crossed it. Swimmers have touched the edges of it. Children have played in the white foam of its outermost breath. Scientists have sent machines down into its darkness to look at what is there. But most of us, most of the time, carry the ocean as a kind of idea rather than a reality. Something we know exists the way we know that stars exist, present and enormous and terribly real, but too large for daily consideration. There is something almost comforting in that vastness, though. Something that works on the body the way deep sounds work on the body, the low rumble of distant thunder, the bass note of a cello, the resonance of a large bell just struck and still humming. The ocean is so vast and so old and so continuous that it exists entirely outside of hurry. It has no urgency. It does not rush. The currents that move through it move on timescales that make our own sense of time feel like the flicker of a candle flame in a long, long night. And there is rest in that, if you let it in. There is permission to be still, to be small, to be one warm and drowsy creature in one small moment of one brief life, on the edge of something that has been here for billions of years and will be here long after every name we have ever given it has been forgotten. So let that image settle in you now, gently, the way salt settles in still water. The world, your world, this spinning blue and white and impossibly beautiful world, wrapped almost entirely in one continuous body of water. 361 million square kilometers of surface, 1.335 billion cubic kilometers of depth and darkness and quiet life. Enough water, if spread evenly, to bury every mountain and fill every valley and cover every shore to a depth of nearly 3 kilometers. 97% of all the water that exists on this planet, held in one unbroken whole, that does not know its own name but goes on moving anyway, tirelessly, without judgment, without hurry, without end. You are lying still right now. Your body is beginning its long nightly work of repair and rest, the soft machinery of sleep beginning to engage at the edges of your awareness, like lights dimming slowly in a large and quiet building. And out there, farther than you can see or imagine, the ocean is moving. It has always been moving. It was moving before you were born, and it will be moving when this night has passed, and the morning comes and then passes in its own turn. It moved when the first fish opened its eyes in shallow, ancient water. It moved when the continents were in different places, and the stars overhead arranged themselves in patterns no human eye had yet learned to name. It is the oldest continuous thing you can point to on the surface of this world, and it is happening right now in the dark, while you breathe and rest and let the day dissolve. Sometimes at night, when everything is very quiet, you can almost feel it, not with your body, but with something deeper. some older part of the mind that remembers, in some wordless way, that water is where everything came from. That the salt in your blood is the same salt that the ocean carries. That the rhythm of your heart is not entirely unlike the rhythm of a tide, reaching and drawing back, keeping time with something larger than itself. It is a feeling that does not have a name in most languages, or perhaps it has a name in all of them, spoken quietly just before sleep. We are only at the beginning. There is so much more to say about this one enormous thing, this ocean that is not many oceans but one, this water that covers so much of the world that the world should perhaps have been given a different name entirely. We have barely touched the surface, literally, because the surface is only the first and shallowest part of what the ocean is. Below it, there are depths that sunlight never reaches. Landscapes more dramatic than anything on dry land. Creatures whose existence seems almost too strange for daylight thinking. And movements and rhythms and histories that go on quietly, whether anyone is watching or not. There are stories inside the water that are older than storytelling, and we have the whole night to begin finding our way toward them. For now, rest in the enormity of it. Let the numbers go soft around the edges. Let the image of a world wrapped in water be not a fact to memorize, but a feeling to carry down into sleep. 71%, one ocean. 1.335 billion cubic kilometers of something that has no hurry and no deadline and no intention of becoming anything other than exactly what it is. Let that be a comfort. The way enormous things can sometimes be comforting, because they remind us that we are held inside something larger than our worries, something older than our fears, something that was here before us and goes quietly on. And as we begin to drift toward the water's edge, we find that the ocean does not begin where the land ends, but rather that it has always been there, waiting beneath. And as we begin to drift toward the water's edge, we find that the ocean does not begin where the land ends, but rather that it has always been there, waiting beneath the thin and fragile crust of everything we have ever known. It waits with a patience that is older than memory, older than the first breath drawn by any creature on this earth, older even than the mountains that pour their snowmelt down into its arms each spring. And as we let ourselves be carried forward, as we release the last of our tension and allow the weight of the day to dissolve the way salt dissolves in warm water, we begin to understand something quietly remarkable. The ocean is not a single thing. It is many things layered one upon another, like the pages of a book so ancient and so vast that no one living has ever read it through to the end. Imagine for a moment that you are floating, not swimming, not struggling, simply floating, suspended at the very surface of the sea, your body held by that gentle rocking cradle of water that has held so many dreamers before you. The sky above you is soft and gray, or perhaps it is deepening into the blue-violet of early evening, and the horizon curves away in every direction as though the whole world is a bowl, and you are resting at its center. Beneath you, the water is clear enough that you can see the sunlight filtering down, threading itself through the surface in long trembling columns of pale gold and green. This is the first and most familiar of the ocean's great layers, the sunlight zone, and it is the only one that most of us will ever know. It reaches from the surface down to a depth of approximately 200 meters, and within that luminous corridor, almost all of the ocean's visible life goes about its quiet and extraordinary business. Phytoplankton bloom in their billions, turning sunlight into food. Fish move in silver flashes through the lit water. Dolphins arc and dive. Whales draw their long, slow breath before descending. Everything here exists in relationship to that light, that warmth, that energy falling endlessly from the sun. But 200 meters is not very far. In the grand architecture of the ocean, 200 meters is barely a beginning, barely a whisper of depth, barely the first step of a staircase that descends for miles and miles into a darkness so complete and so ancient that the human mind must move slowly to comprehend it. When we say that the average depth of the ocean is approximately 3,688 meters, the number sounds precise and scientific, and it is, but what it represents is something closer to a dream. 3,688 meters of water pressing down from above. 3,688 meters of cold and silence and slow, unhurried time. The ocean is not merely wide. It is almost incomprehensibly deep, and that depth is where its greatest mysteries live, where the darkness holds secrets that the sunlit surface has never been asked to keep. So let us descend together, gently, as though we are sinking into sleep itself. Let us move past the 200-meter boundary, where the sunlight releases its last soft grip on the water, and let us enter the twilight zone. That strange and in-between world that oceanographers call the mesopelagic, where the light does not so much disappear as it fades, the way a dream fades in the moments after waking. You can still feel it here, or perhaps feel is too strong a word. Perhaps you can still sense it, a faint luminescence, a memory of blue, a suggestion that somewhere far above there is a world of warmth and color. But the light here is not enough to see by. It is not enough to grow by. It is simply a ghost of the surface, a reminder that the surface exists. And yet even here, in this dim and liminal corridor between the lit world and the dark one, life continues. Strange life, adapted life, creatures that carry their own light within them like lanterns, because in the twilight zone, you must either find the light or become it. The twilight zone descends from 200 meters to approximately 1,000 meters, and as it deepens, the blue fades further, the temperature drops, and the pressure begins to become something you would feel not just on your skin, but deep inside your chest, inside your ears, inside every soft and hollow place within you. This is the nature of the deep ocean. It does not simply surround you. It enters you. It becomes the medium through which all sensation must pass. And there is something about imagining this pressure, this patient, immense weight of all that water above, that is strangely calming, in the way that a heavy blanket pressed gently over your shoulders is calming. The ocean holds its depths firmly, with great and tender weight. Below 1,000 meters, the twilight zone gives way to the midnight zone, and here something shifts in a way that goes beyond the merely physical. The water here is cold, hovering just above freezing in most places, black in a way that daylight black cannot quite approximate, because daylight black is simply the absence of the light we have just seen, while ocean midnight black is the absence of any light that has ever existed in this place at this depth, since the first waters gathered on this spinning young world. No sunlight has ever touched this water. No ray, no beam, no photon from the star at the center of our solar system has traveled this far into the ocean's body. The midnight zone, or bathypelagic zone, as scientists name it, stretches from 1,000 to 4,000 meters, and within its enormous darkness, life continues in forms so unlike what we know at the surface that they seem to belong to a different story entirely. Here there are fish with bodies like nightmares and faces like dreams, creatures with enormous eyes built to catch the faintest biological glow. Creatures with no eyes at all, because eyes require light, and light is a luxury the midnight zone does not offer. Here there are jellies trailing long luminescent threads, anglerfish dangling their eerie lures, transparent organisms drifting through the black water like living glass. Scientists estimate that only about 5% of the ocean floor has ever been explored and mapped in any kind of detail, which means that the vast majority of this midnight world has never been witnessed by human eyes. What lives down there, in those unmapped corridors and unlit valleys, we can only imagine. And our imagination, even at its most creative, almost certainly falls short of the reality. The deep ocean has a way of exceeding us. It has a way of being stranger and more generous with its strangeness than we ever think to anticipate. Let yourself rest in that thought for a moment. Let it settle over you like the soft weight of deep water. 95% of the ocean floor remains unknown, the largest habitat on Earth. The one that covers more than 70% of our planet's surface and extends to depths that dwarf our tallest mountains, remains almost entirely mysterious. We have sent probes to Mars. We have photographed the surface of Pluto. We have built machines that can see light so old it was born in the first moments after the universe itself began. And yet the floor of our own ocean, the dark ground beneath the water that laps at our shores, remains a map of mostly empty spaces, of regions marked simply with depth measurements and guesses, of territories that are geographically near, but experientially as remote as any world in our galaxy. There is something deeply comforting about this, if you allow yourself to feel it in that way. In a world that sometimes feels exhaustively documented, where every street and every mountain and every patch of desert has been photographed and cataloged and pinned to a digital map, the deep ocean remains genuinely, profoundly unknown. It is one of the few places left where the word mysterious is not a romantic exaggeration, but a plain scientific statement. We do not know what lives in 80 or 90 or perhaps even more percent of the ocean's deepest regions. We do not know what forms life takes in those lightless places, what sounds move through that water, what slow and silent processes unfold on that cold and distant floor. The ocean holds its secrets with a grace and a quietness that is almost reverent, and perhaps we should let it, at least for now, at least while we are learning to be still ourselves. Below the midnight zone, below 4,000 meters, the ocean opens into the abyssal zone, and the word abyssal comes from the Greek for bottomless, which is not literally true, but is emotionally accurate. The abyssal zone covers more of the Earth's surface than all of its dry land combined. It is the broad and spreading plain of the deep sea, cold and dark, and still, covered in fine sediment that has been falling from the surface for millions of years. A slow and continuous rain of organic matter that oceanographers call marine snow. This snow, these tiny particles of decaying life and mineral dust, descends through thousands of meters of water, taking weeks or months to make the journey from the sunlit surface to the abyssal floor, carrying energy and nutrients down into the deepest reaches of a world that cannot manufacture its own. The abyssal plain is sustained in part by the deaths of things that lived in the light, a thought that carries within it a quiet and strange kind of poetry. The idea that the deep ocean is fed by what the surface releases, that darkness is nourished by light's leavings. And yet, Even the abyssal zone is not the deepest place the ocean goes. Even at 4,000 or 5,000 meters, we have not yet reached the ocean's true floor, its most extreme and hidden self. That belongs to the Hadal zone, named for Hades, the ancient Greek underworld, and the name is not chosen lightly. The Hadal zone exists only within ocean trenches, those great gashes in the seafloor where one tectonic plate slides beneath another, dragging the crust of the earth downward into the mantle. The Hadal zone begins below 6,000 meters and extends all the way to the deepest point we have ever measured, the Challenger Deep in the Mariana Trench, which drops to nearly 11,000 meters beneath the surface. To put that in a frame that might help the mind to hold it, if you took Mount Everest, the tallest mountain above sea level, and placed it at the bottom of the Challenger Deep, its summit would still be submerged beneath more than 2 kilometers of ocean water. The Hadal zone is not merely deep. It is a different dimension of deep, a depth that requires a complete reimagining of what depth means. The trenches of the Hadal zone are narrow and isolated, like long dark wounds in the seafloor, and each one is its own world, its own pocket of extreme conditions, its own unique collection of organisms that have evolved in isolation over millions of years. Even here, even at these pressures, and in this absolute darkness, life exists. Amphipods, those tiny crustaceans that look something like shrimp, have been found in the deepest trenches in great numbers, scavenging whatever falls from above. Single-celled organisms called foraminifera build their delicate shells and drift through the Hadal water. Microbes cling to the rock and metabolize in ways that should not be possible, in ways that remind us, gently and persistently, that life on this planet is not fragile, but ferocious. Not easily discouraged, but endlessly creative in its will to persist. We are descending now, you and I, slowly through all of these layers, through the sunlit corridor near the surface where the plankton bloom and the dolphins leap, through the twilight where the light fades and the strange fish carry lanterns of their own, through the midnight where no light has ever come from outside, through the abyssal plains where the marine snow falls endlessly and silently, and down now, down toward the narrow trenches, the huddle places, the true floor of the world. And as you descend in your imagination, notice how quiet it becomes. Notice how the sounds of the surface world, the voices and the traffic and the thousand small urgencies of the day seem to belong to some other story entirely. Some brightly lit and busy narrative that has nothing to do with where you are now. You are in the deep ocean or something very like it, and the deep ocean asks nothing of you except stillness. The ocean has been here for billions of years, holding its depths, keeping its darkness, allowing its unknowns to remain unknown. It is not impatient. It is not in a hurry. It turns its slow currents. It cycles its waters from the surface to the bottom and back again over centuries. It keeps its temperatures and its pressures and its chemical balances with a vast and quiet consistency. And in that consistency, there is something that feels, to the drifting and drowsy mind, like safety, like being held, like the knowledge that the world is larger than your worries and older than your fears and more patient than the most patient thing you have ever imagined. Let your breathing slow now just a little. Let the weight of all that imagined water above you become the weight of your blankets, the gentle pressure of warmth and rest. You're not falling. You are descending, which is a different thing entirely. Falling is uncontrolled. Descending is purposeful, even when it is slow, even when it is dark, even when the destination is unknown. The ocean descends through its layers with purpose, each zone distinct and complete, each darkness its own kind of rich and inhabited world. And we are moving through those zones together in no particular hurry, with no particular destination except deeper still, where the last trembling filament of sunlight finally surrenders to the dark. Something extraordinary begins to happen to the pressure, the temperature, and the very nature of deeper still, where the last trembling filament of sunlight finally surrenders to the dark. Something extraordinary begins to happen to the pressure, the temperature, and the very nature of the world as we know it. The ocean, which has always been a place of mystery and movement, becomes something else entirely down here. Something older, something that exists outside the ordinary grammar of the world above. And if you allow your breath to slow just a little, if you let your thoughts drift like particles of marine snow drifting downward through cold and quiet water, you might begin to feel what it would be like to descend into the deepest place on Earth. Somewhere in the western Pacific Ocean, cradled between the islands of Japan and the archipelago of Micronesia, there is a wound in the ocean floor so deep, so vast, so profoundly silent, that it seems less like a geological feature and more like a secret the Earth has been keeping from us since before human memory began. This is the Mariana Trench, and within it, at its deepest and most hushed point, lies a place called Challenger Deep. Say that name quietly to yourself. Challenger Deep. There is something almost ceremonial about the sound of it. Something that asks you to speak in a lower register, to treat it with the reverence we might reserve for sacred places, for ancient cathedrals, for the kind of silence that arrives after a long and complicated day when you finally lie down and close your eyes. Challenger Deep descends to approximately 10,935 meters below the surface of the sea. That number, even spoken softly, is difficult to hold in the mind all at once. 10,935 meters, nearly 11 kilometers. Nearly 7 miles of water stacked above a single point on the ocean floor. To help that number breathe, to give it a shape your imagination can rest upon, consider this. If you were to somehow lift the tallest mountain on Earth, majestic and snow-crowned Mount Everest, and lower it gently into the Mariana Trench, that great peak which reaches nearly 8,850 meters into the sky, would disappear entirely beneath the waves. And still, above its highest summit, there would be more than a mile of dark and heavy ocean remaining. A full mile of water pressing down on a mountain that humans have spent centuries climbing and worshiping and writing poems about. And still, it would not be enough to reach the surface. Close your eyes for a moment and picture that, a mountain swallowed whole. The ocean patient and immense and entirely unbothered by the disappearance. Now imagine descending. Imagine sinking very slowly, the way a feather sinks through still air, or the way your body sinks into a soft mattress at the end of a long day. You pass through the sunlit zone first, where coral reefs glitter and fish dart through cathedral light. Then you pass into the twilight zone, where bioluminescent creatures begin to flicker and glow like living lanterns drifting through purple dark. Then deeper into the midnight zone, where no light reaches at all, where the only illumination in the world is the cold blue-green glow that living things make for themselves. And still you descend. Still the water thickens around you. And the world above grows more theoretical, more like something you half remember from a dream. By the time you approach the floor of Challenger Deep, the water temperature has dropped to somewhere between 1 and 4 degrees Celsius, just above freezing. Cold in the way that deep caves are cold, in the way that mountain nights are cold, in the way that makes the body want to curl inward and find some small warm center to hold on to. It is a cold that has nothing to do with wind or weather or season. It is simply the baseline temperature of a place that the sun has never touched, that warmth has never reached, that exists in a kind of permanent, gentle refrigeration at the bottom of everything. And the pressure? Here is where language begins to strain at its own edges, where the ordinary words we use to describe physical experience start to feel inadequate, like trying to hold water in cupped hands. At Challenger Deep, the pressure is approximately 1,086 bars, over 1,000 times greater than the pressure we feel at sea level, which is to say, over 1,000 times greater than the pressure you feel right now as you breathe softly. As your chest rises and falls, as your body rests easy in the air of your room, 1,000 times. The weight of the entire ocean above, pressing down on every single square inch of anything that dares to exist at that depth. A pressure so enormous, so absolute, that if you were to bring an ordinary styrofoam cup down to Challenger Deep, it would be compressed to the size of a thimble. The air inside it, all those tiny pockets of lightness and buoyancy, simply crushed away to nothing. And yet things live there. But we will come to that in a moment, because first there are the humans. The three improbable, brave, quiet humans who have looked into this abyss and decided to enter it. In January of 1960, a vessel called the Trieste was lowered into the waters above the Mariana Trench. Inside its small, spherical pressure cabin, two men sat and waited for the ocean to accept them. Their names were Jacques Piccard, a Swiss oceanographer, and Don Walsh, a lieutenant in the United States Navy. Two men inside a metal sphere, descending through layers of darkness so thick they might as well have been traveling through solid matter. The descent took approximately 5 hours. 5 hours of slow, patient surrender to gravity and deep water. 5 hours of watching the light above them fade and then vanish completely. Of feeling the cold seep through the hull, of listening to the sounds that metal makes when pressure begins to speak to it in its own language. When they finally reached the bottom, Piccard and Walsh did something quietly extraordinary. They looked out through their porthole into the darkness of Challenger Deep, and in the beam of their searchlight, they saw the floor. Sandy, pale, diatomaceous ooze, the accumulated remains of billions of microscopic ocean creatures who had drifted down over millions of years, building the softest, strangest floor imaginable for the deepest place on Earth. And there, moving across that floor, they saw what appeared to be a flatfish, a living creature, going about its quiet life at the bottom of the world, utterly indifferent to the two astonished human faces peering at it through thick glass. They stayed at the bottom for 20 minutes. Then they began the long, slow rise back toward a world that had light and air and warmth in it. Back toward everything that most of us take entirely for granted. More than 50 years passed. The technology changed. The understanding changed. And in 2012, a filmmaker named James Cameron, who had spent years thinking about the deep places of the world, climbed into a vessel of his own design, a sleek vertical torpedo of a submersible, painted a deep shade of green, and descended alone to Challenger Deep. Alone, a single human being, dropping through 11 kilometers of ocean, sitting in a cabin barely large enough to stand in, carrying with him cameras and sensors, and the particular kind of courage that looks, from the outside, almost like calm. Cameron spent several hours on the floor collecting samples, filming, taking measurements. He later described the experience as feeling like visiting another planet, not metaphorically. Literally another planet, a place so foreign to human experience, so far outside the envelope of everything our bodies and minds evolved to understand, that it required a completely different kind of consciousness to absorb it. 3 people, in all of human history, across all the centuries and all the expeditions and all the instruments and all the accumulated longing of human curiosity, only 3 people have ever stood, in whatever sense the word can apply, at the deepest point on Earth. 3. In the same time that millions of people have climbed mountains and swum in oceans and flown through the air and walked on the surface of the moon, only 3 have gone all the way down to the very bottom of our own world and come back to tell of it. There is something deeply humbling about that number, something that makes you realize how much of our own planet remains genuinely, profoundly unknown to us. We have mapped the surface of Mars with more precision than we have mapped the ocean floor. We know more about the topology of distant moons than we know about the geography of places like Challenger Deep. The deep ocean is, in the most literal sense, the last unexplored frontier on Earth, and it sits below us, patient and dark and impossibly pressured and cold, going about its ancient business without any need of our knowledge or our attention or our names. The floor of the Mariana Trench is covered in that soft, ghostly sediment, billions of years of accumulated quiet, microscopic shells and organic matter, and the residue of every living thing that has ever drifted through the water above and eventually sunk down to rest at the bottom. It is the ocean's memory laid down in layers so slow and continuous that they make human history seem like a brief and excitable afternoon. Down there, time moves differently, or perhaps it does not move at all. Perhaps at Challenger Deep, time simply pools and settles, the way water settles in a deep bowl, still and reflective and going nowhere. The darkness at that depth is so complete that it has its own texture. It is not merely the absence of light. It is the presence of something, a density to the blackness, a quality that feels inhabited even before you account for the creatures that actually live there. It is the darkness that exists before anyone thought to name darkness, before the concept of light existed to give its opposite a meaning. It is the original dark, the baseline condition of the universe before stars began to burn. Sound travels differently down there too. The pressure changes the acoustic properties of the water in subtle and strange ways. The Mariana Trench has been recorded by hydrophones as one of the quietest places in the ocean, and yet also, paradoxically, one of the loudest, because at such depths, sound waves from distant earthquakes and passing ships and the groaning of the tectonic plates beneath your feet all converge and amplify in ways that scientists are still working to fully understand. It is a place that is simultaneously the quietest and the most resonant, hushed on the surface of experience, but full of deep, slow vibration underneath. And the water itself, that cold, dark, impossibly pressured water pressing down on the floor of Challenger Deep. It is ancient water, water that has been cycling through the deep ocean for thousands and tens of thousands of years before it found its way to this place. Water that may have been surface water once, warmed by the sun, part of a wave somewhere, part of a tropical rain, part of a river, before it slowly sank and cooled and descended into the deep circulation of the ocean. the great slow conveyor belt of water that moves through the world on timescales that dwarf human civilization. Every drop of water at the bottom of the Mariana Trench has a history longer than anything we have built or written or remembered. It is old in the way that mountains are old, in the way that the dark between stars is old, in the way that sleep is old, deeper than memory, older than language, reaching back to some original quiet that existed before there was anything to be awake to. The trench itself was formed by the process of subduction, one tectonic plate sliding beneath another, the Pacific Plate diving slowly and inexorably beneath the Mariana Plate, pulling the ocean floor downward into the mantle, creating a crease in the Earth so profound that it might as well be a doorway to the interior of the planet. This process has been ongoing for millions of years. The trench is not a fixed thing. It is a slow event, a geological motion so gradual it makes the word slow seem inadequate. The Earth is always moving, always rearranging itself, always pressing down and pulling apart and breathing in its own enormous, unhurried way. To lie somewhere soft and warm and still, and to know that below you, beneath the floor and the foundations and the bedrock, beneath the sediment and the mantle and all the layered geology of the continents, somewhere impossibly far down, the Earth is still in motion, still pressing and releasing, still creating the conditions that produce places like the Mariana Trench, places that remind us how small we are and how brief and how sweetly, improbably alive. That knowledge has a way of loosening something in the chest, some tightness that the day accumulated, some urgency that borrowed importance from the hours and now, in the quiet, begins to dissolve. Yet even in this place of impossible pressure and eternal night, life has found a way to settle quietly into the stillness, much like the way sleep finds us when we finally stop resisting the drift and simply let ourselves go. Somewhere far beneath the surface of the world, where the last pale thread of sunlight has long since unraveled into nothing, where the weight of an entire ocean presses down with a patience that is almost tender in its enormity, something extraordinary is happening. Something so quiet and so beautiful that it seems less like a fact of nature and more like a dream the ocean is having about itself. Light is being born in the darkness. Not the borrowed light of reflection, not the remembered light of a surface world far above, but true light, original light. Light made from living things that have learned to carry their own small suns inside them. This is the world of bioluminescence, and it is far more common than you might imagine lying here in the gentle dark of your own room. Scientists have come to understand, through careful study and deep wonder, that an estimated 76% of all creatures living in the ocean are capable of producing their own light. 76%. More than 3 out of every 4 beings dwelling in that vast blue wilderness carries within itself the capacity to glow. When you consider how many creatures inhabit the ocean, how many quiet forms drift through its waters in numbers that exceed imagination, that figure becomes something that the mind can barely hold. The ocean is not dark at all. Not really. It is simply lit by a language we are only beginning to learn to read. The light itself is born through chemistry, through a meeting of molecules that seems almost too poetic to be science. Inside the cells of glowing creatures, a compound called luciferin encounters an enzyme called luciferase, and in that encounter, in that soft molecular embrace, energy is released, not as heat, but as light, cold light, clean light, light that costs almost nothing to make and wastes almost nothing in the making. It is one of nature's most elegant solutions, a form of illumination so efficient that human engineers have spent decades trying to understand and imitate it. But the creatures of the deep perfected it long before there were any engineers to admire it, long before there were any eyes above the waves to notice the slow blue constellations drifting far below. And what do they do with this light, these patient, luminous beings? They use it in ways that mirror so many of our own needs. They use it to speak to one another across the darkness. They use it to find food when there is nothing else to see by. They use it to hide, which sounds like a contradiction until you understand the deep sea and its particular logic. Down here in these lightless corridors of water where pressure builds like a slow and ancient breath, every advantage matters. Every trick of light and shadow becomes a question of survival. Communication in the deep takes forms that are almost musical in their complexity. Certain creatures flash signals to potential mates in patterns as specific and individual as a fingerprint, as rhythmic and meaningful as a song. Others use light to warn, to threaten, to declare the boundaries of their small territories in the endless blue-black nothing. There is a whole grammar of light happening in the deep ocean right now. As you listen to these words, as your breathing slows and your thoughts begin to loosen their grip, sentences made of flashes, conversations held in pulses of blue and green, a world of meaning expressed not in sound but in the soft vocabulary of glow. Predation in the deep sea is a thing of strange and dreamlike beauty. Without light from above, without the ordinary visual landscape of the shallower world, hunters and hunted alike have had to develop new strategies, new ways of seeing and being seen and not being seen. Some creatures use their bioluminescence as a kind of torch, illuminating the darkness just enough to spot prey that thought itself safely invisible. Others use it as a lure, which brings us to one of the most iconic and quietly haunting inhabitants of the deep ocean, a creature that seems to have drifted out of the pages of a fairy tale told in the dark, the anglerfish. There is something almost mythological about the anglerfish, something that belongs in the realm of stories told by firelight rather than in scientific journals, and yet here it is, an entirely real creature, living an entirely real life in the cold and crushing darkness of the deep sea. The female anglerfish, for it is the female who carries the famous light, has extending from her forehead a long filament, a modified spine that projects forward like a fishing rod. And at the tip of this filament hangs a small luminous organ that glows with a soft and hypnotic light. In the absolute darkness of the deep sea, this tiny beacon must seem extraordinary. It must seem like a miracle, like a promise, like something warm and safe and worth swimming toward. And that is precisely the point. Small fish and crustaceans, drawn to the light as we are drawn to any warmth in the cold, swim closer to investigate. They follow the glow the way we follow a lantern down a corridor, curious and unaware of the vast open mouth that waits patiently in the shadows just behind the light. The anglerfish does not chase. The anglerfish simply glows and waits, and the darkness does the rest. There is something almost meditative about this strategy, this perfect stillness, this total surrender to patience. The anglerfish has learned that the best way to get what you need is sometimes to simply be still and luminous and let the world come to you. Camouflage in the deep might seem puzzling when we first consider it. How do you hide using light in a world where there is no light? But the deep sea has its own particular demands, and one of them is this: creatures near the surface of the deep, not at the very bottom, but in the middle layers where faint light from above still filters down as a kind of thin and ghostly memory, must deal with the problem of their own silhouette. When a predator looks upward in these intermediate depths, it sees the dim glow of the surface above, and anything between the predator and that distant light appears as a dark shadow, a shape that announces the presence of prey with terrible clarity. Some creatures have solved this problem with bioluminescence used as counter-illumination. They produce light on their undersides that precisely matches the faint ambient glow from above, effectively erasing their own shadow, rendering themselves transparent to anything looking up from below. They become light. They become the background. They dissolve into the water around them, the way a long exhaled breath dissolves into the cool night air of a quiet room. It is camouflage of the most sophisticated kind, and it is powered entirely by chemistry happening in their own bodies, a living invisibility cloak made of cold blue fire. But we need not descend to the crushing depths to witness bioluminescence in its most dreamlike expression. Sometimes the ocean brings its light to us, carries it to the edges of the world where the water meets the shore, where the waves come softly in the darkness, and the sand is cool and the night is full of stars. If you have ever stood at a beach on a warm night and watched the surf glowing an impossible electric blue, if you have ever seen the water itself appear to shimmer and pulse with interior fire, you have witnessed one of the most beautiful phenomena the natural world produces. You have seen dinoflagellates at work. Dinoflagellates are tiny, single-celled organisms, so small that a single drop of seawater might contain many thousands of them, and yet when they gather in sufficient numbers, when the conditions are right and the sea is warm and full of nutrients, they bloom into concentrations so dense that they transform the character of the water itself. Each tiny organism, when disturbed by movement, by the crash of a wave or the passage of a hand through the water, responds by producing a brief flash of blue light. One flash means nothing, but millions of flashes happening simultaneously, triggered by the turbulence of a breaking wave, create something that looks for all the world like the ocean has swallowed a piece of the night sky. Coastlines around the world have witnessed this phenomenon in tropical bays where the water barely moves, in coves where the conditions have concentrated these tiny living lights into something overwhelming. People wade into these glowing waters and trail their hands through liquid blue fire and feel, perhaps, that they have stepped briefly into another world, a world where the boundary between the living and the luminous has dissolved entirely. Swimmers leave glowing trails. Dolphins and fish moving through these bays leave arcs of blue light behind them like brushstrokes. The ocean writes in light, and the alphabet it uses is older than any human language. What is perhaps most extraordinary about all of this, most worth holding gently in your mind as you settle deeper into the soft architecture of sleep, is what bioluminescence tells us about the nature of life itself. Life does not merely survive in darkness. Life responds to darkness with creativity. Life, when deprived of the light it needs, makes its own. It does not wait for the sun to return. It does not simply endure the absence of warmth and illumination. It reaches into its own chemistry, into the molecular conversation happening at the very smallest scale of its existence, and it finds there the capacity to shine. This is not a metaphor, though. It feels very much like one lying here in the soft dark. This is actual biology, actual chemistry, actual life doing what life has always done, which is to find a way through, to adapt, to persist, and to do so with a grace that borders on the miraculous. The deep ocean holds more species of bioluminescent life than any other environment on Earth, and new ones are discovered with a regularity that suggests we have barely begun to map this luminous world. Each new expedition into the deep brings footage of creatures trailing curtains of light, of gelatinous beings pulsing with slow green fire, of fish whose entire bodies are studded with photophores like a living galaxy seen from very far away. The deep sea is the largest living space on our planet, comprising the majority of Earth's habitable volume, and most of it remains unexplored, unknown, unwitnessed except by the creatures who live there and the strange cold light they make for one another. There is something deeply comforting in this, though it takes a moment to find the comfort in it. The thought that there are still vast spaces full of life and light that no human eye has ever seen, that the world is larger and stranger and more luminous than we know. That wonder is not a diminishing resource, but an expanding one. The darkness is not empty. The darkness is full of its own small suns, its own quiet conversations, its own patient and beautiful solutions to the problem of existing in a place where existing seems almost impossible. And as you breathe slowly in the darkness of your own quiet place, consider that somewhere right now, miles beneath the surface of the sea, an anglerfish is holding still and glowing with patient purpose, and a cloud of dinoflagellates is drifting slowly in the black water, waiting for the touch of a wave. And a creature so small it has no name in any language you know is producing a flash of blue light to tell another small creature something important in a grammar of glow that predates every human word for love or longing or hello. The ocean is speaking in light, and the light is saying something very old and very soft, something like the feeling you have just before sleep arrives, that sense of everything loosening, everything brightening slightly, even as your eyes close, everything becoming both smaller and more vast at the same time. The chemistry of luciferin and luciferase produces not just light, but something that feels, when you think about it in the right way, almost like intention, almost like desire, as though the molecules themselves want to meet, want to produce that brief cold flash, want to announce their presence in the darkness, life wanting to be seen even in the places where there is nothing to see it, life insisting on its own visibility, even in the lightless depths. There is something in that insistence that resonates, something that feels familiar in a way that goes deeper than thought. And those quiet blue lights drifting through the deep water move like thoughts we cannot quite hold on to, gentle and slow and endlessly circular, carried along by something far older than memory, something that flows through the entire ocean in great. And those quiet blue lights drifting through the deep water move like thoughts we cannot quite hold on to, gentle and slow and endlessly circular, carried along by something far older than memory, something that flows through the entire ocean in great slow rivers that have no banks, no visible shores, no beginning you could ever stand beside and watch the water start its journey. These are the ocean currents, the vast and unhurried movements of water that wrap themselves around the whole of the planet like a long, slow breath, like the turning of something so enormous and so patient that a single cycle of its movement takes roughly 1,000 years to complete. 1,000 years. Think of that for a moment. If you can hold such a number gently in your mind before it dissolves into sleep. 1,000 years ago, the water now drifting silently through the deepest trenches of the Atlantic was somewhere else entirely, somewhere near a sunlit surface perhaps, feeling the warmth of a sun that shone on a world that had not yet dreamed of the things we now take for granted. And that water has been moving ever since. Slowly carried along by forces so fundamental and so quiet that they ask nothing of us and need nothing from us, and have been flowing long before there were eyes to watch them, or minds to wonder. The system that carries all of this ancient water on its patient journey is called thermohaline circulation, a name that sounds almost like something whispered in another language. Something soft and technical and full of meaning. Thermohaline. It comes from two older words, one meaning heat and one meaning salt. And those two things, temperature and salinity, are the invisible hands that set the whole great system in motion. Water, you see, is not the same everywhere in the ocean. Near the warm tropics, close to the equator where the sun leans down most directly, the surface water is warm and relatively light, and it floats easily, turning slowly in great circular patterns driven by the winds. But as that warm water travels northward, carried in enormous rivers of current toward the higher latitudes, it begins to cool. The air above the North Atlantic is cold, especially in winter, and the ocean gives up its warmth to that cold air generously, slowly. The way a stone that has been lying in the afternoon sun will give its warmth to your hand long after the light has faded. As the water cools, it becomes denser, and as evaporation concentrates the salt left behind in the surface layers, the water becomes saltier too, and saltier water is heavier water, and heavier water, dense and cold and patient, begins to sink. It sinks slowly, and in sinking it begins something vast. Down through the water column it descends, leaving the light-touched surface behind, leaving behind the place where the wind has any say, sinking into the deep, dark places of the ocean where pressure is immense and temperature hovers just above freezing, and the world above might as well be a dream. And there, in those cold, deep corridors, the water begins to flow southward again. A deep river moving through the darkness, carrying its cold and its density on a journey that will take centuries before it rises again somewhere distant, somewhere warmer, somewhere the light can find it once more. This rising, this upwelling of old deep water back toward the surface happens in particular places in the ocean, in the Southern Ocean around Antarctica especially, and along certain coastlines where the winds push surface water aside and allow the deep cold water to climb back toward the world it left behind so long ago. The whole pattern together, the sinking in the cold north, the slow deep drift southward, the rising in the south, the warm surface return, forms a loop, an endlessly repeating circulation that connects every ocean basin on the planet. The Atlantic, the Pacific, the Indian Ocean, the Southern Ocean circling the bottom of the world, all of them joined in one continuous slow movement, one system, one great breathing of the sea. It is sometimes called the Great Ocean Conveyor Belt, and that name gives you some sense of its function, its steady, purposeful transport of water and heat and nutrients and life from one part of the world to another. But a conveyor belt sounds mechanical, industrial, and this thing is neither of those. It is more like something alive, more like the circulation of blood through a body that has been sleeping for 1,000 years. One part of this great system that you may have heard of, perhaps the most famous stretch of moving ocean water in the world, is the Gulf Stream. The Gulf Stream is one of the strongest ocean currents on Earth, a great warm river that flows northward along the eastern coast of North America before crossing the Atlantic toward Europe, carrying with it water that is warmer and bluer, and clearer than the surrounding sea. And the Gulf Stream does not move timidly. It carries approximately 30 million cubic meters of water every single second. 30 million cubic meters. That is a number so large it resists easy imagination. But here is one way to hold it gently. That volume of water moving every second is greater than the combined flow of every river on Earth. Every Amazon, every Nile, every Ganges and Mississippi and Yangtze and Congo, all of them together pouring their water into the sea, and still they would not match what the Gulf Stream moves in a single quiet second of its long passage north. It is one of the great quiet facts of the ocean, something that happens continuously and invisibly while we go about our days, while we sleep, while we dream. And the Gulf Stream does not only move water, it moves heat. Warmth collected near the equator is carried northward in that flowing water and released slowly into the atmosphere as the current travels, and that warmth is not nothing. It is the reason that the western coasts of Europe are as mild as they are, the reason that cities like London and Dublin and Bergen experience winters that are far gentler than their latitudes might suggest. If you were to stand at the latitude of London on the other side of the Atlantic, you would find yourself in the cold, wind-scraped interior of Canada, where winters are long and serious, and the cold is a thing that means business. But London has the Gulf Stream sending its warmth across the ocean, releasing it into the air, softening the edges of the cold. The ocean in this way is not merely a feature of the planet. It is a regulator, a thermostat, a vast, slow system for moving heat from the places that have too much of it toward the places that are hungry for warmth, and in doing so it shapes the climates that life on land has learned over millions of years to depend upon. The tropics, bathed in sunlight, collect enormous amounts of heat, and without some way of distributing that heat, they would grow hotter and hotter while the poles grew colder and colder, and the difference between them would become something the planet could barely sustain. But the ocean currents act as mediators, as the gentle and ancient diplomats of the climate system, carrying warmth poleward and returning cooler water to the tropics to be warmed again and sent back out on its long, slow circuit. They smooth the extremes. They make the world more habitable. They distribute not only heat, but nutrients as well, bringing cold, deep water rich with minerals up to the sunlit surface where tiny plants called phytoplankton can use them. And those phytoplankton feed the small creatures, and the small creatures feed the larger ones. And the whole great chain of ocean life is threaded through with these invisible rivers of moving water that make everything else possible. There is something almost meditative about the scale of it, about the thought of water that left the surface of the North Atlantic 1,000 years ago, still moving, still flowing, still carrying out the same patient circuit it began before any living person now on Earth was born, before their great-great-grandparents were born, before the distant ancestors of those ancestors drew their first breath. The ocean does not hurry. It has never hurried. It began circulating in patterns, something like these, long before humans appeared on the shores to watch and wonder. And it will continue long after the last of our questions has been asked. There is something deeply restful about that, if you let the thought settle into you, rather than trying to hold it in place. The ocean is older than our worry. It is older than our need to understand. It moves in its great loops and gyres and deep cold rivers, not because anything has asked it to, not because it is trying to accomplish something, but simply because the laws of water and heat and salt have always worked this way, and the planet has always turned. and the sun has always warmed some places more than others. And so the water moves. Imagine, if you can, being a single particle of water on that long journey. You begin near the surface, somewhere in the North Atlantic, feeling the cold of winter pulling the warmth out of you. You feel yourself becoming heavier, denser, sinking slowly down through water that grows darker and colder with every meter of descent. You leave the wind behind. You leave the light behind. You settle into the deep and begin your long, slow movement southward through the Atlantic Basin, around the bottom of the world, through the vast, cold waters of the Southern Ocean. Carried on currents that move so slowly you would not notice the movement from one year to the next, drifting through the Indian Ocean into the Pacific, rising slowly somewhere in the warm tropics where upwelling carries you back toward the light you left behind 1,000 years ago. And then you're at the surface again, warm in the sun, and the long, slow journey begins once more. A cycle so vast that a single human life, even a very long one, is only a small fraction of the time it takes to complete. And yet the system completes itself, again and again, reliably, patiently, connecting every ocean basin, every depth, every temperature, in one continuous, unbroken circulation. The fact that all the ocean basins are connected in this way, that the Atlantic and the Pacific and the Indian Ocean are not separate, isolated bodies of water, but parts of one continuous system, is one of the more quietly astonishing things about the planet we live on. You could, in principle, follow the water from anywhere to everywhere, given enough time, given enough patience. The ocean that touches the shore of one continent is in contact, slowly and over centuries, with the ocean that touches every other shore. The water is all one water. The currents are all one current, braided and looped and threaded into a single system that holds the climate of the whole world in its slow and powerful embrace. It connects the poles to the tropics, the deep to the shallow, the ancient cold of the abyss to the warm surface where the light plays, and the dolphins leap, and the surface of things is bright and full of motion. And all of this is happening right now as you rest, as you breathe, as your own thoughts slow and begin to drift. Somewhere in the deep Atlantic, water that fell from the surface centuries ago is moving southward through the dark, carrying cold and salt and the memory of a colder world. Somewhere in the tropics, the sun is warming the surface of the sea, setting in motion the very first steps of a journey that will not be completed for 1,000 years. The Gulf Stream is flowing north this very moment, carrying its 30 million cubic meters every second, warming the air above the ocean, keeping the edges of distant winters softer than they would otherwise be. The upwelling zones are drawing cold, deep water up toward the light, feeding the invisible forests of phytoplankton that make half the oxygen in every breath you take. The conveyor belt turns. It has always turned. It will keep turning long after this night has passed, and the morning has come and gone, and many more mornings after that. There is a rhythm to it. Once you let yourself feel it rather than think it, not the quick rhythm of a heartbeat or the familiar rhythm of breath, but something slower and more ancient, the rhythm of water that moves through the world the way time moves through everything, without urgency, without pause, without any particular hurry to arrive. And these currents move through the water the way breath moves through a sleeping body, unhurried and necessary, and so deeply woven into the rhythm of the living world, that without them the very seasons themselves would soften and blur into something. These currents move through the water the way breath moves through a sleeping body, unhurried and necessary, and so deeply woven into the rhythm of the living world that without them, the very seasons themselves would soften and blur into something unrecognizable, something wild and unbalanced, and far removed from the gentle procession of warmth and cold that we have always known. And so when we speak of the ocean, we are speaking of something more than water. We are speaking of the great regulator, the quiet keeper, the vast and patient heart that beats beneath the surface of everything we know about living on this particular blue world. Close your eyes for a moment, if you have not already, and imagine the ocean not as a place you visit, but as a force that visits you every single day in every single breath. It is there in the air that fills your lungs right now, in the temperature of the room around you, in the slow and invisible machinery that keeps this planet from swinging wildly between extremes, too harsh for anything soft and living to survive. The ocean does not announce itself. It does not ask for recognition. It simply works, as it has always worked, with a kind of breathtaking and quiet devotion that makes the word dedication feel almost too small. Think of the carbon dioxide that drifts upward from our cities, from our roads, from the factories and the engines and all the burning and building that has defined the last few centuries of human life. Much of it rises into the atmosphere and stays there, accumulating like a slow and warming blanket around the world. But a remarkable portion of it, roughly 30% of all the carbon dioxide produced by human activities since industrialization began, never quite makes it to permanence. It drifts down toward the surface of the sea, it touches the water, and the ocean breathes it in. This is not a metaphor, or not entirely. The chemistry is real and it is wondrous. Carbon dioxide dissolves into seawater the way sugar dissolves into warm tea, slowly and completely, and with a kind of molecular patience that spans years and decades and centuries. The ocean draws this carbon down through its layers, incorporating it into the great chemistry of the deep, binding it into the bodies of tiny organisms, pressing it toward the floor in particles so small they are invisible to the naked eye. And in doing so, the ocean softens the edges of a problem that would otherwise be far sharper, far more immediate than the one we already face. Without the ocean's willingness to absorb that carbon, the atmosphere would be heavier, warmer, more changed than it already is. The ocean holds a portion of our consequences inside itself, quietly and continuously, and we are only beginning to understand the full depth of what that means. But carbon is not the only thing the ocean has been quietly absorbing on our behalf. There is heat too, and so much of it. Since the industrial era began, since the great engines of human civilization first began to warm the atmosphere in ways that accumulated over generations, the ocean has been accepting that excess heat into itself. More than 90% of the additional warmth generated by climate change over this entire period has been absorbed by the sea. 90%. That number, when you sit with it in the quiet of a sleepy mind, is almost beyond comprehension. The ocean has taken the vast majority of the heat that would otherwise have been reshaping the atmosphere, the land, the living world above its surface. And it has pressed that heat down into its own blue depths, where it mixes and moves and slowly redistributes itself across the planet. This is what it means for the ocean to be a heat reservoir. Imagine a great slow-warming stone placed in the center of a home, absorbing the cold of winter night and releasing it gently through the small hours before dawn. The ocean does something like this, but on a scale that makes every human-built thing seem small and fleeting. It takes in heat during the long warm seasons and releases it through the cold ones. It warms the coastlines of continents that would otherwise be far less hospitable. It moderates the temperature of the air that blows inland, carrying its breath of stored warmth into mountain valleys and river plains and cities that have no idea how much they owe to the water they may never have seen. The oceans act as this massive heat reservoir for the entire globe, softening the swings between day and night, between summer and winter, between one side of a continent and another. Places that sit close to the sea rarely experience the brutal cold snaps or the searing heat waves that afflict the interiors of land masses, where the ocean's moderating influence cannot quite reach. The water remembers warmth longer than the land does. It gives it up more slowly, more gently, as though reluctant to let go of the comfort it has stored. And this quality, this thermal patience, this slow and capacious holding of temperature shapes everything. It shapes where animals can live and what they can eat and when they breed. It shapes where rain falls and where the deserts spread and where the forests grow thick and lush and green. It shapes the flow of winds across entire hemispheres because the atmosphere and the ocean are in constant conversation, exchanging heat and moisture and motion in patterns so intricate and interconnected that even our most powerful computers are only beginning to trace the full beauty of their dialogue. The ocean does not regulate temperature in isolation. It regulates it in partnership with the sky, in a relationship so ancient and so essential that the two can barely be understood apart from each other. Now let your mind drift a little further, down toward the sunlit upper layers of the sea, to a world invisible to the naked eye but fundamental to everything you are. In those bright, shallow waters, in the zone where sunlight still penetrates and life crowds toward the warmth and the light, there exist organisms so small that billions of them would fit into a single glass of seawater. They are called phytoplankton, and they are, in every sense that matters, among the most important living things on Earth. Phytoplankton are not animals. They are not quite plants either, though they share one essential thing with every plant you have ever seen growing in a garden or a forest or a field. They photosynthesize. They take sunlight and water and carbon dioxide, and they transform these raw materials into energy, into life, into the organic matter that forms the very base of the ocean's food web. And as a byproduct of this transformation, as a kind of incidental gift released into the water, and from there into the air, they produce oxygen. So much oxygen, an almost incomprehensible quantity of oxygen released silently into the sea and sky by creatures you would need a microscope to see. Phytoplankton and the marine algae that drift alongside them in those sunlit waters are responsible for producing roughly half of all the oxygen in Earth's atmosphere. Half. Every second breath you take, measured in the broadest and most humbling sense, comes not from the forests and the meadows and the green growing things of the land, but from the ocean. From those invisible drifting billions, doing their quiet photosynthetic work in the upper skin of the sea, exhaling oxygen into a world that would suffocate without them. Marine algae and phytoplankton are responsible for the oxygen in nearly every other breath a human takes. When you breathe in right now, in the soft, dim quiet of wherever you are resting, there is a real and scientific sense in which the ocean is breathing with you. The oxygen in your lungs carries within it the legacy of countless phytoplankton blooms, of green and golden clouds, of microscopic life spreading across the surface of a sun-warmed sea. doing the ancient patient work of turning light into air. This has been happening for billions of years, long before the first fish swam, long before the first amphibian pulled itself onto land, long before the first creature breathed air as we understand breathing. The oxygen revolution, the great transformation that made complex animal life on Earth possible, was in large part the work of the ocean. Cyanobacteria, the ancestors of modern phytoplankton, in some deep evolutionary sense, began producing oxygen through photosynthesis more than 2 billion years ago, slowly filling an atmosphere that had previously been hostile to the kind of life we now take for granted. The sky above us is, in the most literal sense, a gift from the sea. The atmosphere that makes this planet livable, that filters the harsh radiation of the sun, that traps enough warmth to keep liquid water flowing in rivers and pooling in lakes, was built by ocean life over geological time, breath by invisible breath. And this continues now, right now, in every ocean basin, in every sea and gulf and sheltered bay where sunlight touches water. Phytoplankton are blooming and dying and releasing oxygen in quantities we can measure but can barely imagine. A single teaspoon of ocean water may contain hundreds of thousands of individual phytoplankton cells, each one going about its quiet photosynthetic work, each one contributing its fraction of oxygen to the great shared atmosphere we all breathe together. From the surface of a city to the peak of a mountain, to the interior of a continent, thousands of miles from the nearest coast, the air carries oxygen that was born at sea. There is something profoundly settling about this, something that quiets the mind in the way that deep truths often do when we allow ourselves to really receive them. We think of breathing as something we do alone, in the privacy of our own bodies, an automatic and self-contained process. But breathing is anything but solitary. It ties us, in the most intimate and biological sense, to the ocean, to the phytoplankton, to the chemistry of seawater and the physics of sunlight passing through clear blue water, and the ancient evolutionary history of life, learning to turn light into oxygen on a young and spinning world. When the ocean is troubled, as it increasingly is, when the waters warm beyond the tolerance of certain phytoplankton species, when the chemistry of the sea shifts as it absorbs more carbon and becomes more acidic, when the clarity of the water dims or the circulation patterns slow, these are not abstract environmental concerns. They are concerns about breathing. They are concerns about the very foundation of the atmosphere on which all animal life, including every sleeping and waking human being, depends. The ocean's health and our health are not parallel tracks. They are the same track, moving in the same direction toward the same horizon. But tonight, in this quiet hour, we are not here to carry worry. We are here to rest inside wonder, and the wonder is real and it is vast. The ocean has been doing this work for longer than our minds can truly hold. Longer than the mountains have been mountains, longer than the continents have been arranged in the shapes we know. It has been moderating temperatures and absorbing carbon and breathing oxygen into the sky through ice ages and tropical epochs and every kind of planetary shift that the long, strange history of Earth has seen. It is patient in a way that puts human patience to shame. It is generous in a way that asks nothing in return. Let the thought of it settle over you now like something warm and weightless. The ocean holds you at a livable temperature without your asking. It cleans the air you breathe without your knowing. It has been tending the atmosphere since before there were creatures with lungs to breathe it. It is the quiet infrastructure of life, the invisible maintenance the deep background hum of planetary health that makes every other living thing possible. And somewhere out there right now, in the dark water, under a sky full of stars, or a sky full of clouds, or a sky just beginning to pale at the edges, with the first suggestion of a dawn that has not yet arrived, phytoplankton are floating in their millions and their billions, going about their ancient work, photosynthesizing, releasing, giving, contributing their small and vital breath to the atmosphere of a world they will never know is inhabited by creatures who spend their nights lying still and warm and completely dependent on the gifts of the sea. Every breath you take right now carries within it a gift from the sea, a molecule of oxygen that was once exhaled by a tiny creature floating near the surface of some sunlit patch of ocean, drifting with the current beneath a sky that looked very much like every breath you take right now, carries within it a gift from the sea, a molecule of oxygen that was once exhaled by a tiny creature floating near the surface of some sunlit patch of ocean, drifting with the current beneath a sky that looked very much like the one that hangs above you now, whether you can see it or not. Whether it is dark and full of quiet stars or soft with the gray of early morning, that molecule has traveled so far to reach you, and it carries with it, invisibly, something of the ocean's own nature, something of its deep and patient chemistry, something of the water itself. And now we find ourselves slipping downward, past the surface where the light plays, and the wind stirs the waves into long, rolling hills of blue and silver, past the place where the phytoplankton drift and photosynthesize in their billions, past the thermocline where warm water meets cold in a slow, invisible embrace. We are moving towards something older now, something that has been quietly present for longer than almost anything else on this turning world. We are moving toward the water itself, the chemistry of it, the ancient salt dissolved within it, the invisible library of elements that the ocean holds within its vast and patient body. Seawater is not simply water. If you were to take a single liter of it into your hands, you would feel it the same way you feel any water, cool or warm depending on where it was gathered, moving with that familiar liquid grace between your fingers, but dissolved within that liter, woven invisibly through every molecule of hydrogen and oxygen, is approximately 35 grams of dissolved salts. 3.5% by weight is salt. It does not sound like very much, written that way, as a fraction, as a small number. But when you begin to imagine it spread across the whole of the ocean, across every bay and basin, and deep trench and polar sea, and warm tropical lagoon, the number becomes something almost incomprehensible, something that the mind must approach slowly, the way you approach something beautiful and overwhelming, with gentleness, with willingness to be astonished. The salt in the ocean, if it could somehow be gathered, drawn up from every liter of every sea, dried and crystallized and laid out across all the land on Earth, every continent, every desert and mountain range and rolling plain, would form a layer approximately 166 meters thick. 166 meters of pure crystalline salt, glittering under whatever sun might remain, higher than most buildings you have ever stood beside, higher than many trees. A great white mineral blanket covering the entire surface of the land. That is how much salt the ocean holds. That is the quiet abundance of it. The primary salt is sodium chloride, the same mineral that sits in small shakers on kitchen tables, the same one that seasons a bowl of soup on a cold evening, the same one your body uses to carry electrical signals from nerve to nerve to keep the fluid balance of your cells in careful equilibrium. The ocean is full of it. But sodium chloride, familiar as it is not the whole of the story. The ocean also holds magnesium and sulfate and calcium and potassium, and these too are dissolved salts, contributing to the complex, layered chemistry of seawater in ways that matter enormously to the creatures that live within it, to the way sound travels through deep water, to the freezing point of polar seas, to the density that determines whether a body of water sinks or rises or stays where it is, turning slowly in the dark. What is extraordinary, what might keep you gently awake for just a moment longer before sleep takes you fully, is the stability of all this. The ocean's salinity, that 3.5%, has remained relatively stable for hundreds of millions of years. The continents have moved, mountains have risen and eroded, species have come into being and passed away. Ice ages have locked enormous volumes of water into glaciers and then released them again in great slow floods of meltwater. The atmosphere has changed its composition. The sun has grown slightly warmer. Everything has shifted and transformed in the great patient dance of geological time. And yet the ocean's saltiness has stayed, held in a kind of dynamic equilibrium, balanced between the rivers that bring new dissolved minerals down from the land and the slow processes that remove salts from the water, the creatures that build shells from calcium carbonate, the seafloor sediments that absorb certain ions, the chemical exchanges between seawater and the rocks of the oceanic crust. It is a balance maintained over timescales so vast that the word ancient feels almost too small for them, too brief, too human in its scope. Rivers are always bringing salt to the sea, carrying it dissolved from rocks worn down by rain and frost, and the slow mechanical work of water moving over stone. Every river that reaches the ocean brings with it a small tithe of minerals, a quiet contribution to the great dissolved inventory of the sea. And yet the ocean does not grow saltier with time, or at least not measurably, not over the span of human civilization or even the span of recorded geological history. The system finds its balance. It has been finding its balance for so long that it has become, in a sense, one of the most stable chemical systems on the surface of the Earth. An ancient equilibrium maintained through processes so slow and so vast that they are nearly invisible to anything with a human lifespan. But here is where the chemistry of the ocean becomes something that feels almost like magic, or perhaps something better than magic, something truer and stranger and more beautiful than any invented enchantment. Dissolved within seawater, in trace amounts so small they might seem insignificant, are virtually every naturally occurring element on the periodic table. Every one of them, the same chart that hangs on the walls of school classrooms, with its rows and columns of elements arranged by atomic number. Each one a different kind of matter, each one with its own weight and behavior and history, forged in the hearts of stars. Nearly all of them are present, somewhere dissolved in seawater. Some in large amounts, like sodium and chloride. Some in moderate amounts, like magnesium and calcium. And some in quantities so vanishingly small that the word trace does not quite capture how little is there, parts per trillion. Dissolved ghosts of elements carried by rivers and rain and hydrothermal vents and the slow chemical weathering of the seafloor. There is lithium in the ocean, and rubidium, and cesium, and barium. There is iodine, which seaweeds concentrate from the water into their tissues and which eventually finds its way through the eating of those seaweeds or the creatures that ate them, into the thyroid glands of animals and humans. There is bromine, dissolved in quantities large enough that the ocean is the primary source of bromine for human industry. There is uranium, spread thinly through the water in concentrations so dilute as to be harmless, but present nonetheless. That heavy and ancient element that powers the slow radioactive decay, keeping the interior of the Earth warm after all these billions of years. There is iron, though only in tiny amounts in the open ocean, and this scarcity matters enormously, because iron is a limiting nutrient for phytoplankton in many regions of the sea. And in places where iron is scarce, the ocean is almost a biological desert, clear and blue and beautiful and nearly empty of microscopic life. And then there is gold. Take a moment with that. Let the word settle. Gold, the metal that has captured the human imagination for as long as human beings have had imaginations capable of being captured. The metal of treasure and desire and ancient ceremony, and the faces of kings pressed into coins. Gold is dissolved in the ocean, not in nuggets, not in flakes, not in any form that could be seen or felt or gathered. It is dissolved at a concentration of perhaps 13 parts per trillion, which is to say it is essentially invisible, essentially nothing. And yet the ocean is so vast and so deep and holds so much water that those parts per trillion add up over all that volume to something almost beyond imagining. The total amount of gold dissolved in all the world's oceans is estimated at around 20 million tons. 20 million tons of gold. More gold than has been mined by all the civilizations that have ever existed in all of human history, dissolved invisibly in the water. Held within the chemistry of the sea as lightly and as completely as any other element. No one has ever found a way to extract it economically. The water itself resists this kind of taking. The gold is simply too dilute, too perfectly dispersed, too thoroughly mixed into the vast body of the ocean for any technology yet devised to gather it at a cost that would make the gathering worthwhile. And there is something right about this. Something that feels almost intentional. Though of course it is only chemistry, only the mathematics of concentration and volume and energy. The ocean keeps its gold. It holds it in solution, dissolved in the cold, dark water miles below the surface, in the warm shallows of tropical seas, in the ice-edged waters near the poles. The gold is everywhere in the ocean and nowhere you can reach it, and the ocean is simply indifferent to the fact that it holds it. The way the ocean is indifferent to so much. The way something ancient and vast is indifferent to the small and urgent desires of creatures who have only been here for the briefest moment of geological time. And there is something calming about this, if you let it be. The ocean is not withholding anything. It is simply being what it is, a vast chemical solution, a slow and patient keeper of elements, a place where the minerals of the earth have been dissolving and cycling for longer than there have been eyes to see it or minds to wonder at it. The gold is there the way everything is there because the chemistry allows it, because the rivers brought it, because the hydrothermal vents exhaled it, because the rocks of the seafloor slowly dissolved it into the water column over timescales that make the whole of human civilization look like the brief flicker of a match struck in a dark room. You are lying still somewhere right now, your body warm, your breath slowing. Perhaps you can feel the slight heaviness of your limbs, the way sleep pulls at the edges of your thoughts like a gentle tide. Let it pull. There is nothing you need to hold on to. The chemistry of the ocean will continue its ancient work, whether you are awake or dreaming. The salt will stay dissolved in its precise proportions. The trace elements will continue their slow cycling. The gold will remain suspended in the cold, dark water, 20 million tons of it, going nowhere, in no hurry at all. Think for a moment about your own blood, about the fluid that moves through you right now, carrying oxygen from those distant phytoplankton through your lungs and out to your cells, returning with carbon dioxide to be exhaled, to travel perhaps back someday to the sea. Your blood is salty. It has a salinity, a concentration of dissolved ions that is roughly similar to a diluted form of seawater, not identical, not the same percentage, but built from the same fundamental chemistry. Sodium and potassium and calcium and magnesium and chloride, the same cast of elements, playing slightly different roles in a slightly different solution. This is not a coincidence. This is history. This is the long memory of the body, the record of the fact that life began in the sea, that the first cells arose in a salty medium and built their internal chemistry to reflect the chemistry of the water around them, and then carried that chemistry inward with them when, hundreds of millions of years later, some of their descendants found their way onto land and kept it, protected it inside sealed bodies, inside skin and shell and scale, bringing a small ocean with them wherever they went. You're carrying a small ocean inside you, the salt in your blood, the ions in your cells, the careful chemical balance your kidneys maintain every moment of every day. All of it is a kind of inheritance, passed down through so many generations of ancestors that the chain of them stretches back past the first fish, past the first animal, past the first cell with a nucleus, all the way to the ancient ocean itself, to the warm, shallow waters where chemistry became biology, where molecules began to copy themselves, and the whole extraordinary story of life on Earth began its first uncertain chapter. And the same ancient minerals that season the sea have been cycling through the ocean and the atmosphere and the bodies of living creatures for so long that the salt in your own blood carries a kind of memory, a faint and distant echo of, and the same ancient minerals that season the sea have been cycling through the ocean and the atmosphere and the bodies of living creatures for so long that the salt in your own blood carries a kind of memory, a faint and distant echo of something older than words, older than the first creature that ever crawled from the shallows onto dry land and blinked at the open sky. And that memory, if you were to follow it back far enough, would lead you here to the edge of the water, to the place where the sea breathes in and breathes out, with a patience so enormous that we can only really feel it if we slow ourselves down to match it. If we let ourselves become still enough to listen, the sea breathes. That is not merely a poetic idea. It is, in its way, a true thing. Every single day, the oceans of the world rise and fall, pulled and released, in a rhythm that has been going on since long before any human being stood on any shore and watched the water come in. The force behind this breathing is the moon, our moon, the same pale disk you have seen rising over rooftops and fields and mountain ridges, the same soft light that has guided travelers and poets and wolves and lovers through uncountable nights. The moon reaches down across 238,000 miles of empty space and wraps its gravity gently around the water of the earth, and the water responds. It cannot help but respond. Gravity is patient and insistent, and it does not ask permission. The way it works is quietly wonderful. The moon's gravitational pull is slightly stronger on the side of the earth that faces it, and slightly weaker on the far side. This difference in pull, this gentle gradient of force across the diameter of our planet, is what creates the tides. The water on the side closest to the moon is pulled toward it, bulging outward into a high tide. And on the opposite side of the Earth, the water bulges outward too, but for a subtler reason, because that far side is being pulled less strongly than the solid Earth beneath it, and so it lags behind, pooling into its own quiet mound of water. Two bulges, two high tides, on opposite sides of the world at once. And as the Earth rotates beneath those bulges over the course of a day, any given stretch of coastline passes through both of them. Two high tides, two low tides, every single day, but not quite every 24 hours. And this is where the rhythm becomes interesting, becomes more complex, like a piece of music with an unexpected time signature. It takes approximately 24 hours and 50 minutes for the tidal cycle to complete itself, because the moon is also moving, slowly orbiting the Earth. And the Earth has to rotate just a little bit further each day to catch up with where the moon has drifted. 50 extra minutes, accumulating quietly, shifting the tides a little later each day. The way a song played at a slightly slower tempo will drift out of sync with the one you were humming in your head, and so the tide does not arrive at the same time every morning. It comes when it comes, on its own unhurried schedule, indifferent to clocks and appointments and the particular plans of the day. The sun is part of this story too, though it plays a supporting role. Even though the sun is vastly larger than the moon, it is also vastly farther away. And in the mathematics of tidal forces, distance matters enormously. The result is that the sun contributes only about 46% as much tidal force as the moon. Still significant, still enough to matter. When the sun and moon align, pulling in the same direction at new moon and full moon, their forces combine into something stronger, and the tides swell higher and fall lower than usual. These are called spring tides, though the name has nothing to do with the season. It comes from an old word meaning to leap, to surge, and that is what the water does, surging upward as though reaching for something. And when the sun and moon are at right angles to each other, their tidal forces partially cancel out, and the tides become more modest, quieter, the soft-spoken tides called neap tides, which arrive in between, like a gentle rest between the louder passages of the music. There is a place in the world where all of this tidal force is concentrated into something almost impossible to believe. The Bay of Fundy, on the eastern coast of Canada, where the provinces of Nova Scotia and New Brunswick reach out toward each other and form a long funnel of coastline that narrows as it goes, like a channel designed by nature for the specific purpose of amplifying what the moon sends in. The shape of the bay, its length and depth, creates a resonance, a kind of sloshing rhythm that matches almost perfectly the frequency of the tides. And when the tidal energy pours in, it has nowhere to spread, nowhere to dilute itself, and so it rises. It rises to heights that seem impossible. In some parts of the Bay of Fundy, the tide comes in by more than 16 meters, 53 feet of water arriving and departing twice a day, every day, with mechanical regularity. 16 meters. That is the height of a 5-story building, rising and falling, the sea climbing the cliffs and barnacled rocks and retreating again, leaving the ocean floor exposed to the open air, strange and ribbed and covered in the small creatures that have learned to live in both worlds, the wet world and the dry one, belonging completely to neither. If you have ever stood on a tidal flat and felt the particular quality of silence that settles there at low tide, you will know what it is to sense time moving differently. The mud is full of tiny histories. The water is gathering itself just beyond the horizon's edge, preparing to return. And there is something almost meditative about waiting for it, about knowing with absolute certainty that it will come back, that the coming back is as inevitable as anything the natural world has ever promised. The moon gives the sea its rhythm, and in exchange, the sea gives something back. The interaction between the earth and the moon is not a static thing. It is dynamic, evolving, slowly changing over millions and millions of years. The tides create friction. As the oceans slosh back and forth, pulled by the moon, the water rubs against the ocean floor, against coastlines, against the shallow continental shelves. And this friction acts as a kind of gentle brake on the Earth's rotation. The days were once shorter. Long ago, before the moon was as far away as it is now, before the continents had drifted into their current arrangements, the Earth spun faster, and the days lasted only a matter of hours. Gradually, imperceptibly, that spinning has slowed, and the energy that bleeds out of the Earth's rotation does not disappear. It is transferred through the gravitational interaction between Earth and Moon into the Moon's orbit, nudging it gently outward. The Moon is moving away from us, not quickly, not in any way you would notice in a lifetime or 100 lifetimes, but by about 3.8 centimeters every year, the Moon drifts a little farther into the dark. It is like watching someone you love walk slowly away down a very long road, barely moving, and yet moving, always moving. This drift is measured with lasers, retroreflectors left on the lunar surface by the Apollo astronauts bounce laser pulses back to Earth, and scientists time those pulses with extraordinary precision. And from those measurements, they can track the Moon's slow recession year by year. The universe is measurable, even in its poetry. Even the slow goodbye between a world and its moon can be expressed in centimeters and seconds. And there's another thing quieter still that the tides do. Not just to the water, but to the very rock beneath your feet. The gravitational pull of the moon does not stop at the ocean's surface. It reaches into the solid body of the Earth itself, and the solid Earth, which we think of as fixed and permanent and entirely unyielding, responds. The ground rises and falls with the tides, not by much, perhaps 30 centimeters at most, in the places where the effect is strongest. But the land breathes too, in its own slow way, stretching and relaxing as the moon passes overhead, as the sun adds its smaller voice to the gravitational chorus. This is called the Earth Tide, and it is entirely real, and it happens beneath us constantly without our awareness, without our consent, without our participation. The planet itself is being gently kneaded by the gravity of its neighbors, flexing like something alive, something vast and patient and quietly responsive to forces it has been living with since the beginning. There is something deeply settling about this, if you let yourself feel it fully. The idea that even the solid ground is not entirely solid, that even the rock and the deep crust and the ancient bones of the continents are participating in the same dance as the water, the same slow, rhythmic response to the moon. Nothing is as rigid as it seems. Everything is moving. Everything is in relationship with something else. Everything is responding always to some gentle pull from somewhere outside itself. The water moves because the moon calls it. The rock moves because the moon calls it. And you, lying here in the warmth of wherever you are made of the same minerals as both, And the same forces that move the oceans and flex the continents are passing through you right now, silently, tenderly, without your knowing. Let the rhythm of the tides settle over you now. 2 high tides and 2 low tides, arriving a little later each day, unhurried and precise and ancient beyond imagining. The Bay of Fundy, where the sea climbs 5 stories twice a day and leaves the world dripping and revealed. The moon drifting away at the pace of a slowly growing fingernail, year by year, decade by decade, carrying with it the memory of every tide it has ever pulled. The earth breathing beneath the water and beneath the land, flexing its vast body in response to a gravitational whisper from across 250,000 miles of space. This is the rhythm that underlies all other rhythms, older than the rhythm of your breathing, older than the rhythm of your heartbeat, though both of those are there too, layered on top of the deep tidal pulse like melodies over a slow and steady bass note that has been playing since before there were ears to hear it. The sea has always been rhythmic, the moon has always been steady, and together they have been marking time in a way that makes all of our clocks and calendars seem like very recent and very human inventions, which of course they are. The water pulls toward the moon, and then the earth turns and the water falls back, and the shore is revealed for a little while, the wet sand gleaming. The small pools left behind catching the light like scattered mirrors, holding crabs and starfish and the translucent eggs of things that have not yet become themselves. And then the water comes back. It always comes back. It has never once failed to come back. And there is something in that faithfulness, in the reliability of that return, that is profoundly, wordlessly comforting. The tide will come back. The moon will be where it always is. The rhythm will continue long after everything you are worried about has resolved itself or dissolved entirely into the long afternoon of time. Breathe with it for a moment. In with the tide, slow and rising and full. Out with the tide, retreating, soft, releasing. You do not have to hold anything right now. You do not have to keep the shore in place or make sure the water remembers to return. These things will happen without your help, exactly as they have always happened, exactly as they will always happen. The moon will rise, the sea will answer, and somewhere on a beach that is cold and dark and beautiful and entirely unconcerned with anything except the present moment, the tide pulls back from the shore, the way sleep pulls back the edges of the waking world, slowly and inevitably, leaving behind only the smooth, wet sand and the last of the day's light gleaming across something half-buried, something smooth and pale, and shaped by 1,000 years of the tide, pulls back from the shore the way sleep pulls back the edges of the waking world, slowly and inevitably, leaving behind only the smooth, wet sand and the last of the day's light gleaming across something half-buried, something smooth and pale and shaped by 1,000 years of water moving over it, turning it, holding it in its soft and patient grip, the way the ocean holds everything eventually, not with force, but with time, with the kind of deep and unhurried attention that only the sea knows how to give, and it is in this spirit of unhurried attention that we begin to descend now, slowly, gently, past the shallow tide pools and the kelp forests and the continental shelves with their soft sediment and their slow-falling snow of organic matter, descending further now into a place where the light no longer reaches, where the world grows quiet in a way that even silence on land cannot quite imitate. Because this is not merely the absence of sound, but the presence of pressure, the presence of depth, the presence of a landscape so vast and so old and so continuously reshaping itself that the mind grows still just trying to hold it. Imagine, if you can, as you lie here breathing softly, that the floor beneath the ocean is not flat. Perhaps you have always imagined it as a kind of blue plain, stretching away into darkness, featureless and still, the way the surface of a lake looks from above on a windless morning. But the truth is something far more dramatic, far more geological, far more alive with slow-motion drama than any surface landscape you have ever seen. The ocean floor is a world of mountains and valleys, of ridges and trenches, of towering volcanic peaks and wide basaltic plains, of cracks in the earth so deep they could swallow entire mountain ranges whole, and all of it draped in darkness, all of it moving, all of it alive in the geological sense, in the deep, slow-breathing sense, in the sense that the earth itself has lungs and a heartbeat and a rhythm that operates on a timescale we can barely imagine. Let us begin with the mountains, because they are the first thing that astonishes. Beneath the sea, stretching across the ocean floor like a great continuous spine, like the backbone of the planet itself, there runs the longest mountain range on Earth. Not the Himalayas, not the Andes, not the Rockies or the Alps or any range that rises into sunlight and holds snow on its peaks. The longest mountain range on Earth lies entirely beneath the sea, and it is called the Mid-Ocean Ridge System, and it stretches for more than 65,000 kilometers through every ocean basin on the planet. 65,000 kilometers. Let that number breathe for a moment. If you could somehow lift this mountain range out of the water and lay it across the surface of the land, it would circle the Earth more than once, winding through every continent, threading through every valley, dwarfing anything we have ever named or mapped or stood upon. And yet most people have never heard its name, have never seen its image, have never thought about the fact that the largest geological feature on our planet is one we cannot see from the surface. One that exists in permanent darkness, one that has been building and shifting and rumbling quietly for hundreds of millions of years without anyone walking along its ridgelines or watching the clouds move over its peaks. The mid-ocean ridge is not merely a mountain range in the way we might think of mountains. It is also a wound in the earth, or perhaps not a wound, but a seam, a place where two tectonic plates are slowly pulling apart, moving away from each other with the same imperceptible patience that a flower takes to open in the morning, millimeters per year, centimeters per decade, but continuous, relentless, and producing as they move apart a constant upwelling of molten rock from the mantle below. This is where the ocean floor is being born. This is where new seafloor rises from the interior of the earth in rivers of dark lava, cooling almost instantly in the freezing water, solidifying into long, flat plains of basalt that spread outward from the ridge in both directions, like the pages of a book slowly opening. And this is why the ocean floor is so young compared to the ancient rock of the continents. Most of the seafloor is less than 200 million years old, a geological infant compared to continental rocks that can be 4 billion years in age. The ocean floor is constantly being made and remade, carried away from the ridge on either side, spreading outward over millions of years until it eventually reaches the edge of a continent and dips downward into a subduction zone, sliding back beneath the Earth's crust and melting once again into the mantle from which it came. A slow circle, a deep breathing, the planet inhaling and exhaling on a timescale so long we experience it the way we experience the movement of a clock's hour hand, not moment to moment, but only when we look away and look back again. And because the ocean floor is being born at the mid-ocean ridge, because liquid rock is continuously pushing up through that great seam in the earth, the ridge is also a place of extraordinary volcanic activity. More than 80% of all volcanic activity on Earth occurs underwater. Not on land, not in the dramatic eruptions we see photographed and filmed and reported on the news, but beneath the sea, along the mid-ocean ridge, and in other volcanic zones scattered across the ocean floor. 80%, the Earth is constantly erupting, constantly releasing pressure from its interior, constantly reshaping itself, and almost all of that reshaping happens in the dark, in the deep, in the cold and pressured silence of the seafloor, where no one is watching, where the lava moves slowly through the water and solidifies into strange bulbous shapes called pillow basalts, rounded and stacked like cushions pressed together, the geological record of eruptions that no human eye has ever witnessed in real time. Though we have sent small unmanned vehicles down to find their traces and bring back images that look almost like something from another world, there is something deeply calming about this if you let yourself feel it. The Earth is always at work, always releasing, always creating, and it does this in the deepest quiet, in the deepest dark, without drama and without audience. The way certain essential things always happen, the way your heart beats while you sleep, the way your cells renew themselves in the hours before dawn. The planet has its own slow metabolism, its own long breathing, and you are resting on the surface of something that is, in its own geological way, very much alive. And then there are the vents, perhaps the most astonishing places on the ocean floor, perhaps the most astonishing places on Earth, and they exist in places you would never expect life to survive. Hydrothermal vents are cracks in the seafloor through which water, heated by the volcanic activity below, rises back up through the rock and erupts into the ocean. But this is not merely warm water. This is water superheated to more than 400 degrees Celsius. Water so hot it would flash instantly into steam if it were at the surface under normal atmospheric pressure. But at the depths where these vents exist, the pressure of the ocean above is so immense that the water cannot become steam. It remains liquid even at these extreme temperatures, pouring out of the seafloor in dark plumes called black smokers because the minerals dissolved in the water precipitate out as it meets the cold ocean, turning the plume dark and cloudy, billowing upward into the water column like smoke from a chimney, like breath from a sleeping giant beneath the stone. And around these black smokers, in the complete darkness, in the extreme heat, in the chemical-rich water that would be poisonous to almost any organism we know from the surface world, there is life. Extraordinary life. Tube worms that grow as long as 2 meters, clustering around the vents like fields of pale flowers, swaying gently in the current of hot water. Ghostly white crabs moving slowly across mineral chimneys, eyeless shrimp gathering in the warmth. Communities of organisms that do not depend on sunlight at all, that base their entire existence not on photosynthesis, but on chemosynthesis, on the energy contained in the chemicals pouring from the vents, sulfur compounds and methane and hydrogen, an entirely different foundation for life, an entirely different relationship between an organism and its world. When scientists first discovered hydrothermal vent communities in the 1970s, it changed what we thought we knew about life itself, about where it could exist, and on what terms, and in what relationship with light and heat and chemistry. The ocean floor told us that life finds a way even in the most extreme and unlikely places, that warmth and chemistry and time are perhaps more fundamental to living things than sunlight, that the dark interior of the earth is not empty, but teeming in its own slow and extraordinary way with forms of existence we are only beginning to understand. And scattered across the ocean floor between the ridges and the trenches and the vent communities, there are the seamounts, underwater volcanic mountains that rise from the seafloor, some dramatically, some gradually, but all of them creating their own local ecosystems, their own upwellings of nutrient-rich water, their own gathering places for marine life, drawn to the structure and the circulation they create. The seamounts number in the tens of thousands, perhaps more than that, perhaps far more, because we have mapped so little of the ocean floor in high resolution that many seamounts surely remain undiscovered, rising silently in the dark from seafloor plains we have never closely examined. Their slopes perhaps covered in coral gardens and sponge forests and fish communities that have never been seen by any human instrument. There is something gentle and humbling in this, the knowledge that tens of thousands of mountains exist beneath the ocean, and many are still unknown to us, still waiting in patient darkness. Growing so slowly they do not seem to grow at all on any timescale we experience, but growing nonetheless, built from lava that rises and cools and accumulates over millions of years until what was once a crack in the seafloor becomes a hill, and what was once a hill becomes a mountain that approaches the surface. And some seamounts rise all the way to become islands, breaking through the surface of the water into light and air, and becoming the kind of place where birds land and plants grow and rain falls. The kind of place we name and visit and call home, though their roots extend deep into the dark ocean floor, where they began as nothing more than a weakness in the rock and a slow upwelling of heat. The ocean floor, when you let your mind settle over it like water over stone, is a landscape of deep time. Every feature on it tells a story that takes millions of years to tell. The spreading ridges speak of plates moving apart, of the Earth's interior exhaling through stone. The seamounts speak of volcanic hotspots fixed in the mantle, while the plate above moves slowly over them, leaving a chain of mountains in its wake, like footprints pressed into soft ground. The trenches speak of plates colliding, one diving beneath the other with slow inevitability, creating the deepest places on Earth. Places where the pressure is so great it feels less like a place and more like a condition, a state of being. A darkness so complete and a weight so total that even the idea of it induces a kind of stillness. And all of this is happening right now tonight, as you breathe softly and let your body grow heavy and your thoughts grow slow and loose. Right now, the mid-ocean ridge is releasing heat. Right now, somewhere on the seafloor, a column of superheated water is rising through a hydrothermal vent into the cold darkness above it. Right now, a seamount is adding another infinitesimal layer of basalt to its slopes, growing so slowly that no instrument could measure it tonight, and yet growing continuously, patiently, in the dark. Right now, the seafloor is spreading, pulling apart at the seams, making room for new rock, new ocean, new landscape that will take millions of years to arrive at the margins and descend again. The planet is working. The planet is always working. And it does so with a patience that makes our longest human timescales feel like the blink of an eye, like the brief flicker of light between sleeping and waking. Like the moment when you're not quite one thing and not quite another, but somewhere in the deep middle of both. Let your breathing slow a little more. Let your body sink a little further into the surface beneath you. Think of the ocean floor as something alive with slow motion. Think of the mountains rising and falling across geological time, the lava cooling into stone, the stone moving outward, the plates carrying their cargo of seafloor across the dark and pressing it eventually back into the Earth's interior, where it melts and becomes part of the mantle again, part of the deep, hot interior that feeds everything that happens above it. Every ridge and vent and seamount, every island that breaks the surface, and every trench that drops below it. The Earth is not a fixed thing. It is a process. A long, slow, beautiful process operating at a depth and a time scale that makes our brief human lives feel like a single note in a symphony that has been playing since before the first ocean formed, before the first water fell from the sky or rose from the interior, before the first wave broke on the first shore and the first tide pulled back from the first beach and left behind its smooth, wet offerings. Somewhere beneath 65,000 kilometers of underwater mountain, somewhere in the darkness below the seafloor, below even the lowest point of the deepest trench, there is heat. There is always heat. The Earth has been cooling since its formation, and it will continue to cool for billions of years more. And in the meantime, that heat finds its way to the surface through every crack and seam and vent it can discover. Through the mid-ocean ridges and the hydrothermal chimneys and the volcanic hotspots that feed the seamounts, the heat of the planet's interior moving slowly outward toward the cold of space. And in between those two extremes, in the narrow range of temperatures that make water liquid and chemistry possible and life sustainable, everything we know exists. Beneath the weight of all that water, the mountains rise and fall in slow motion across millions of years, the ocean floor spreading apart at the seams like a dreamer slowly opening hands during sleep, releasing warmth into the darkness from somewhere deep within the Earth itself, from the place where stone becomes something like breath, where the planet exhales its oldest heat into the cold and waiting dark. And here, in this detail, in this slow and ancient exhaling, is where the story of everything alive begins. Not with a trumpet sound, not with a sudden flash of lightning splitting open the sky, though perhaps lightning played its part in other tellings, in other possible beginnings scattered across the surface world. Here, deep beneath the reach of sunlight, at the border between molten stone and freezing seawater, something happened that changed the nature of this planet forever. Something so small it had no name, no awareness of its own smallness, no sense of the enormity of what it was beginning. A collection of molecules finding themselves arranged in a particular way, a particular chemistry, discovering a particular possibility, a tiny folding of matter into a pattern that could repeat itself, that could persist, that could reach toward whatever resources the warm and mineral-rich water offered and use them to continue. Life began in the ocean, or at least this is what the evidence gently suggests, what the rocks and the chemistry and the deep logic of biology whisper when we know how to listen. Somewhere between 3.7 and 4 billion years ago, in water that had been pooling and shifting and cooling over the surface of a young and restless planet, the first living things quietly appeared, not as drama, not as spectacle, as the most ordinary, extraordinary thing that has ever happened in the known universe. The hydrothermal vents, those warm and mineral-breathing chimneys rising from the ocean floor, are among the most favored candidates for this beginning place. Scientists who study the origin of life look at these vents with something close to reverence because they offer so much of what early life might have needed: warmth, without the hostility of open flame, minerals, drawn up from deep within the Earth's interior, offering iron and sulfur and magnesium and all the elemental building blocks of biological chemistry. Tiny porous chambers within the rock structure of the vents themselves, almost like miniature rooms where molecules could gather and concentrate rather than simply dispersing into the vast surrounding ocean, where reactions could happen in sequence, one leading into another, building something more complex from something simpler over and over again across enormous stretches of time. Time is the ingredient we so often forget. We think of 4 billion years as a number too large to feel. And it is. It truly is. No human mind can hold it whole. But perhaps we can feel the edges of it. 1 billion seconds is approximately 32 years. 4 billion years is not merely a long time. It is a duration so deep that the word long becomes insufficient, becomes almost a kind of humor. And in all of that depth, in all of that slow and patient turning of the planet, life did not simply begin once and stop. It kept going. It elaborated. It branched and diversified and discovered new ways of being alive in the particular conditions of the ocean, which were themselves always shifting, always offering new pressures and new possibilities across the geological ages. The ocean, even now, holds more living space than anywhere else on Earth. It contains the largest habitat on the planet by volume, a three-dimensional world of unimaginable scale, where creatures can live not only at the surface or on the floor, but at every depth in between. In the sunlit shallows, and in the perpetual midnight of the deep, in the polar waters where ice forms and melts with the seasons, and in the warm equatorial currents that carry warmth around the globe like a slow and generous river. The majority of life on Earth lives within this water, not on the land we walk on, not in the soil we tend, not in the air we breathe, but in the ocean. This has always been true, since before there were any creatures capable of knowing it, since before there was anything on land at all, when the continents were simply bare rock under an ancient sky, and the ocean was already teeming, already ancient, already deep in its long project of becoming. And even now, after centuries of human curiosity, after all the voyages and the dredges and the sampling bottles lowered on long cables into the dark, after all the submersibles and the sensors and the satellite tracking systems and the careful hands of taxonomists working through collections in quiet museum rooms, the ocean keeps its secrets with extraordinary ease. Scientists estimate that somewhere between 700,000 and 1 million species make their home in the ocean. That number alone is enough to make the mind go quiet with wonder. 1 million different ways of being a living thing in the water. 1 million different shapes and metabolisms and life histories and strategies for surviving and reproducing and finding food and avoiding being found. And then comes the part that is perhaps the most extraordinary of all. Of those vast numbers, scientists believe that as many as 2/3 of ocean species have not yet been discovered, have not yet been found, described, named, or understood. 2/3 of the life in the largest habitat on Earth remains unknown to us. They are living their lives right now, in the darkness or in the light, in the cold or in the warmth, going about whatever it is they do with no awareness of our not knowing them, with no need of our naming them, complete in themselves in a way that is both humbling and somehow deeply comforting. There is something tender about this, something that settles the mind rather than disturbing it. Though it might seem at first like it should disturb, like the unknown should feel frightening. But perhaps in the gentleness of a half-sleeping mind, in the soft and loosening hour before dreams come, the unknown can feel instead like abundance. Like the world being larger than our accounting of it. Like the ocean saying quietly and without urgency, "There is more here than you have yet imagined, and this is not a problem. This is a gift. This is the endless offering of a planet still full of itself, still going about its ancient work of making and sustaining life." The first creatures to live in the ocean had no eyes to see its darkness. They had no nervous systems to register the pressure of the water around them, no awareness in any form we would recognize. They were chemistry that had learned to persist, nothing more and nothing less. And from that impossibly simple beginning, across all those billions of years of slow elaboration, came everything. Came the first cells with a nucleus, which took perhaps another billion years to appear, so unhurried is the pace of deep time. Came the first multicellular organisms, creatures made of many cells working in coordination, which opened up new possibilities of size and specialization. Came the soft-bodied ancestors of nearly everything alive, creatures we can see in certain ancient rocks as ghostly impressions, the outlines of forms that no longer exist, experiments that life tried and then set aside. Came the first creatures with eyes, which changed the ocean's social world in an instant of evolutionary time, introducing the new dimension of being seen, of being visible, of predator and prey in an arms race that has never quite stopped since. Came the fish. Eventually, and the move to land by some of those fish across hundreds of millions of years, and the long history of life on the continents that we tend to think of as the main story, because it is our story, because we are the descendants of those creatures that left the water, because we carry in our own bodies the memory of ocean in the salt of our tears and the salt of our blood, in the way our embryos pass through stages that echo the forms of ancient aquatic ancestors, in the simple fact that our cells are still mostly water, still doing their chemical work in a solution that remembers the sea. But the ocean did not empty when some of its creatures left. It continued. It kept elaborating, kept diversifying, kept finding new forms and filling new niches, kept being the largest and most complex habitat on Earth, kept harboring within it the majority of life, kept being home to creatures so strange and so beautiful that each new discovery reads like a chapter of a story that has been going on much longer than anyone was there to read it. The anglerfish hanging its pale light in the abyss, drawing the curious toward it in the dark. The mantis shrimp with its eyes that perceive colors beyond the range of anything we can imagine, seeing the world in a spectrum of light that is simply not available to us. The octopus thinking its distributed thoughts through the neurons spread across its arms, each arm with a kind of intelligence of its own, a creature whose consciousness, if we can call it that, is organized so differently from our own that to understand it even a little is to understand that mind can take more forms than we had supposed. The coral reef building its limestone city over centuries, a living architecture that houses more species per square meter than almost any habitat on land. A world of color and movement and intricate relationship that persists through time in a way that no single organism within it will ever witness in full. And still beyond these, in the parts of the ocean we have barely touched, in the trenches and the deep plains, and the cold seeps where methane rises from the sediment and supports communities of creatures that live on chemistry rather than sunlight, in the midnight zone and the hadal zone and the ancient mud of the abyssal floor. There are the 2/3 we have not found yet, the ones living undescribed lives in undescribed places, part of the same unbroken lineage that stretches back to those first molecules, arranging themselves in warm mineral water 4 billion years ago. Part of the same continuous story that has never paused, that has never needed us to be aware of it in order to proceed, that goes on in the deep and ancient dark with the quiet confidence of something that has always known what it is doing. The ocean does not hurry. It has never hurried. It received the first living things without ceremony, and it holds their descendants now, billions of years later, in the same unhurried embrace. The water that surrounded the first organisms on Earth is still here, still moving, still cycling through evaporation and rain and river and return, still carrying its cargo of salt and mineral and life from one part of the planet to another in the vast, slow circulation that connects every ocean to every other ocean. That makes the sea not many places, but one continuous place, the same body of water that has been washing over this planet since before there was anything alive to be washed over. To think about the ocean before sleep is to think about deep time made tangible, about a history so long it becomes something like eternity, about a place so full of life that most of that life remains invisible to us, about a beginning that is still, in some sense, always beginning, always generating new forms, always discovering new ways of being alive in the particular chemistry and pressure and temperature of whatever water a creature finds itself inhabiting. The ocean began this story. It held the first breath of life in its mineral warm water, and it has been holding life ever since, patient and vast and mostly undisturbed by the awareness of the small land creatures who occasionally dip their instruments into its edges and call what they find a discovery, while the ocean simply continues being itself, being ancient, being full, being the deep and original home of nearly everything that has ever been alive on this small and fortunate planet turning in the dark. Somewhere right now, in water that has never been sampled, in a depth that no instrument has yet reached, something is alive that science does not know the name of, going about its quiet and complete existence in the blue and ancient dark, as it has always done, as the ocean has always allowed, resting in the oldest home there is. And so we let the deep, dark waters carry us gently now, cradling us the way the ocean holds every secret shore. This journey through the tides has quietly come to rest. If sleep has not yet found you, the next chapter waits, soft and unhurried whenever you are ready. But for now, breathe slowly like the ocean breathes. Good night, dear one. Drift beautifully.